This lesson is on factorising by completing the square. Now, before we get to the factorising component of this, we need to know what it is to complete the square and how we do it. So, if we want to complete the square for this expression here, x squared plus bx, all we need to do is add b on 2 all squared. Now, the reason we do that is because what we're trying to create when we complete the square is a perfect square. We're trying to create a perfect square. So it's important for you to remember what a perfect square is. So we've got it over here. Perfect squares, a plus b all squared is equal to a squared plus 2ab plus b squared, and similar for a minus b all squared. So when we're completing the square, we're trying to create a perfect square. So what that looks like is if we have x squared plus bx, and then as I said we add on b on 2 all squared, that gives us x plus b on 2 all squared, and therefore we've created a perfect square. So let's have a look at a couple of questions. If we want to complete the square for x squared plus 10x, we need to add on b on 2 all squared. Now our b here is the 10. This is our b. Add 10 on 2 all squared, which equals x squared plus 10x plus 10 on 2 is 5 squared, and we can write that out again as x squared plus 10x plus 25. But the question's actually asking us to complete the square, which we've done, and then factorize. Now, as you saw before, in factorized form, when we complete the square, we're creating a perfect square. So in factorized form, the answer is going to be x plus b on 2 all squared. Our b on 2 was 5, so in factorized form, this is going to be x plus 5 all squared. Let's work through another one together. Complete the square for x squared minus 7x. Now straight away, hopefully you'll notice that this is slightly different to the previous question because our b is actually negative. Our b is negative 7. So if we complete the square, we'll get x squared minus 7x plus minus 7 on 2 all squared. Now you'll notice the fact that it's negative doesn't change the last term in our expression. Because we're squaring it, it's always going to end up being positive. So x squared minus 7x plus minus 7 squared is 49 over 2 squared is 4. But the fact that we've got a negative here does impact our final answer. This is still a perfect square, but if in factorized form it becomes x minus 7 on 2 all squared. So notice the difference. X squared minus 7x. If we complete the square, we know that as a perfect square it's going to be a negative here. In the previous question, x squared plus 10x, when we completed the square, the perfect square was a positive. So that process was mainly focusing on completing the square. Now I'm going to give you a couple of questions where we've got some quadratic expressions, and I want you to factorize them by completing the square. So the first one we'll look at is x squared plus 8x minus 3. Now, when we want to factorize by completing the square, the first thing we need to do is actually complete the square. So x squared plus 8x, we need to add on 8 over 2 all squared, so that's the b on 2 all squared. But to keep the expression balanced, we actually then need to subtract this 8 over 2 all squared, and then we've still got that minus 3 on the end. We can't just add 8 on 2 all squared and then write minus 3, because that's actually changing the whole expression that we had to begin with. So in order to keep the expression balanced, once we've completed the square here by adding 8 over 2 all squared, we then need to subtract it, 8 over 2 all squared. Now, what I'm going to do to help us is actually put this component here of the expression in brackets, because that is the component where we've created a perfect square. So hopefully you recall from the questions above that that perfect square will become x plus 8 over 2 is 4 all squared, and then we come over to this component of the expression, 8 over 2 all squared is 4 all squared, so minus 16 minus 3. We can keep going with that. X plus 4 all squared minus 19. Now, it's important to realize that what we've created here is a difference of two squares. So hopefully you recall that a squared minus b squared equals a minus b, a plus b. That's what we've created here. Let's keep going. X plus 4 squared minus root 19 squared will give us x plus 4 minus root 19, x plus 4 plus root 19. And now we've fully factorized that original quadratic. Let's have a look at one more. So same process, we'll factorize by completing the square. X squared minus 2x plus 8. So we'll get x squared minus 2x plus minus b on 2, so that'll be minus 2 on 2 all squared. I'll put all of that in brackets because that component there is the perfect square that we've created. But then we need to subtract minus 2 on 2 all squared to keep the expression balanced. And then we've got that 8 on the end. Let's keep going with this. So this will become x minus 2 over 2 all squared is just 1. So that would become x minus 1 all squared minus 1 plus 8, which gives us x minus 1 squared minus 1 plus 8 is plus 7. Now, you'll notice that we've got a plus here. This is really important because the fact that this is plus 7 means that this is not a difference of two squares. A difference of two squares follows this identity, a squared minus b squared. It has to be a minus. So we cannot go any further with this and factorize. So our final statement is just that. Therefore, x squared minus 2x plus 8, so our original expression, cannot be factorized. We were certainly able to complete the square as we did here, but the fact that it wasn't a difference of two squares means that it couldn't be factorized. So hopefully that's been a helpful introduction to factorizing by completing the square.